I'm going to give you a quick rundown of the Chainletter Webhook API. It's still in beta, so some things may change, but it's a pretty powerful tool that only has a few different routes you have to consume using an API key that you get from your client portal. Now, this powerful API lets you do a lot of the same things that the client can do, but you can do it on your own website, hosted in your own environment. You can also integrate it into different products and services. This website here is using the OpenAPI specification that's provided in the code to create a display that lets you test and browse all the different features that are available in this API. I'm going to assume that if you're continuing with this tutorial that you're kind of used to REST APIs and used to consuming them using Fetch or Axios or whatever your favorite tool is. Now this API does not have that many things in it, but the few things that it has let you build a client app that's almost the same as our official one. So the things you can do are you can list files or groups, or you can get verification data for a specific file. You can upload a file, you can create a group, you can delete a file, you can stamp a collection, which includes stamping single files because you would add a file and then stamp and then add a file and then stamp. You can get the status of different objects in the system using the head. And there's this pretty unusual endpoint where you kind of can start listening for server sent events, SSE. This is something that's a kind of a different protocol where your client will get live updates from the server as different events happen. So demoing that will be a little tricky, but we'll get to it as part of this demonstration. Since this video is probably posted as part of a GitHub repo, I'm going to assume that you've already downloaded the samples GitHub. So I have that open here. It's just called Product API File Browser, and it was available as one of the repos that I've put up as a public repo under the MIT license. Now in here we have 8 examples that are of different degrees of complexity. Now the first example kind of shows off all the features at once in a pseudo app. It's a file browser app that's almost feature complete. It's missing a few things that would be needed for a real app, but it shows off lazy loading and image loading patterns and different ways of consuming all the different endpoints that are available. And I use this one to kind of test all the endpoints. And we also have ones that show you how to create different kinds of files locally without even engaging our server. We have ones that show how to listen for those events. So I'm going to show you how to start engaging with this API. The first thing you're going to want to do is install all the node modules folders into all of the different example folders, because each one of them serves as a standalone app. So we've created a convenience script called install all, which you just run by running npm run install all in the root directory of the Product API file browser. Since I've already done this once, it's going to be very quick. Since most of the packages are already deployed, just installing them one after another. Hopefully this succeeds. If it doesn't succeed, you're going to have to just run npm install individually on whatever folders are not working. So they've all been installed. I'm going to type CLS and clear the screen. And we're going to start with example 1 because it shows off everything that you can do in the API, and then I'm going to break it down into some of the other examples. So we're starting with the most complex example first. So we would do npm run ex1, and running ex1 starts it running on localhost port 3040, which I'm going to open in a browser. So you can see that our example has loaded, and our example is showing the total number of files in our test server that we've set up, how many credits we have remaining, total size. So these stats are coming from one of those special stats calls, the head calls. And if we go in and click on view groups, this should look like a pretty typical file folder structure for a file browser. So these are all the folders that we have in our collection, whether or not they're public or private. Now it doesn't say how many files are in each one because it's a little bit more advanced, a little trickier to get. But if I look into one of these folders, you'll see that they contain a bunch of files, they contain a bunch of images. As I scroll, it's loading the images into view. If I click on one of the files, we'll get verification data, so it'll show you the hash of the file, it'll show you whether or not it's been stamped to the blockchain, it lets you download it, delete it. And if I find one that is stamped, we'll get more information. So it shows you the contract that it's been stamped under, the hash for the file, when it was created. Now there's more information that's available, but in this demo I kept it really simple. We're not trying to actually recreate our entire client application, we're just trying to show off how someone could use this as a starting point to kind of make their own. So let's say we're going to upload a file to this group nt1. You can see I just have a bunch of test certificates here. They're random. I generated them myself. So we're just going to grab one, Marvin Kovac, number 471, and I'm going to click on open. You can see we've uploaded the file. It should appear in this list. Here it is at the bottom. It hasn't completely loaded yet. And that's where server-side events come in. So if I click on this little bell, you'll see that the whole time that we've been doing anything in this system, it's actually been listening for events that happen, and it's been recording them in this list. So you can see that we established a connection a few minutes ago, and then I just uploaded this file. So it says that I uploaded it, and then when it's pinned, it means it's actually available to re-download to display again in this website. So you have to listen for different events, uploaded and pinned. And there's other events that can happen too, like if I create a new group, I'm just going to call it T2. It's going to be public. We'll click create, and you can see we have a group created. If I go into the NT2, I'm going to click on upload file, and I'm going to browse my hard drive again, and we're going to pick 2049. We're going to upload Benny Braun, and you can see here in our events, file was uploaded, hasn't been pinned yet. And now it's been pinned, and you can see now it's been pinned, it started loading, and it loaded in. So there's a little bit of a delay between when you upload a file and when it's been processed. It's actually going up to an image resizing service. It's going to cloud hosting. There's a lot of things that are happening in the background. So you just want to give your users kind of an interactive view. There's also ways you can instantly display images, but they're using kind of hacks by drawing it to a canvas. That's beyond what this tutorial is about. These are kind of most of the functions. So if we go and we could delete this file if we want by clicking on the file details. We can see it's not stamped, so delete file is available. I deleted it. If I go back to the groups, I can go and I can upload another one. And then we're going to stamp it. So I'm going to go pretty low on the list. Dolores, somebody. Okay, I've uploaded this file. You can see our events we're getting quite a few of them now. And if I click on stamp collection, now it's created the postmark file that represents this image. If I click on that, you can see that we can actually see the contents of this JSON file. This isn't usually visible to customers, but this is how you can confirm that the hash of your image was actually included on the blockchain ultimately. So this contract should contain this hash and this hash ending in FF7D for the SHA and TSMWJ for the CID. If we go back to our Dolores, we have TSMWJ, so this actually means that postmark file that we stamped contains the hash of this other file, which is how we know that we have blockchain confirmation. So this is most of what the Chainletter platform is made to do, and it's done in this small little demo. So that pretty much concludes example 1. The rest of them are much smaller, and I'm going to just jump into them now. So we're going to close example 1. I'm going to go back into our cursor window. We're going to kill the process for example 1. And we're going to do something a little different. We're also going to open another PowerShell, and we're going to run example 4. Example 4 is our server-side event listener, and you can see now that we've started listening for server-side events in a process that's different from the process where we're going to be doing our demos. This is how you could do something like on your home page, show all the credentials that are passing through your system in a live feed. This is how you could post them automatically to social media. There's a lot of things that you can do using this kind of listener. So we're going to view the listener, which is its own page, which I think I clicked. I did click. You can see we've opened up our Webhook event stream, and as we do things in the other examples, they should show up here, which is, I think, a really powerful tool. Okay, so if I go back to my cursor window, we're going to load example 2, which is a quiz. And what this quiz is going to show us is the process of basically issuing a single certificate, stamping it right away, and also giving someone a link where they could claim it for their profile. So we can see that the example 2 is loaded on port 3042. So I clicked on the link, it should have opened. We have a math quiz. So for this example, I'm going to fill in the correct answers, 8, 19, and 40. I'm going to put in my username is going to be, I don't know, July Demo 1. And if I click on Submit Quiz, it's just issued us a certificate nearly instantly. It was stamped right away, but the transaction ID is not yet available. We can refresh our status until we see it, but it generated this image on the fly of a certificate file that we could download and post wherever we want. It got the transaction ID, I just manually refreshed. And we should be able to see in our event stream all of those steps. So look, it uploaded it, stamped it, pinned it, and then we got the result of the pinning. We got this image. So now that our certificate has been issued by this quiz, we can go in and either download a copy, which will just give us the file that's verifiable, or we can view it on IPFS. And if this has been issued, there's ways to give someone a claim link to claim the certificate, but I must not have included it in this demo, so I'll definitely do that later on. Okay, so moving on, we'll close this quiz. That's the example of how to stamp a file right away. It uses more stamps, which is the kind of currency that we have in our platform. It's not a crypto, it's just normal credits that like any website that uses credits might have. But it's kind of our way of limiting or doing like pay-per-use, however we want to do it. Okay, I'm going to go back into Cursor and we're going to run example, I'm going to kill that one, we're going to run example 3. You can see all the events that we've been logging in our website are also being logged to the console here. Example 3 is the upload and stamp. Super simple. It's just this function. It literally just takes a file, it generates a file from the current date and time, posts it to our endpoint as a file with stamp immediately set to true. So it stamps it. This is the kind of minimal code you need to engage this API and create a blockchain verifiable file, which I think is pretty cool. So we go back to our running window, we run example 3. You can see that it just ran through the steps, uploaded the timestamp, file successfully uploaded, and then it stamped the timestamps collection that contains all of the timestamps. And we can see in our event log, it uploaded timestamp.txt, stamped it, and then the file was pinned, meaning it was uploaded to our cloud storage. I can run it again. We can watch the events. Another timestamp was added, uploaded, collection was stamped, and we'll get a pinned notification at some point once the pinning service runs again. Might take a second. There it is. So not too long. So you'd have a fairly interactive experience for your user. Okay, so that was example 3. Example 4 has been running. It's the events. Example 5 is a cost saving schedule. So we're going to run that. npm run ex5. That's running on port 3045. I click the link, opening it in my web browser. Oh, and our event stream also, even though it was in the background, it's still running. So we can see these timestamps. So scheduled file stamping. This is your way of kind of saving money when you're using the API. Let's say that you have a very popular online course and every hour you have, I don't know, 15 students complete it. You don't necessarily want to pay 15 stamps an hour for each individual student completion. You may want to pay 1 stamp for 45 completions, every 3 hours, or you may want to pay 1 stamp an hour to limit your spend to 24 stamps a day, or you might want to just stamp. In this example, it's stamping at noon and midnight. So you'd know that your spend would be 2 stamps a day, and that kind of blockchain confirmation would be granted on a specific time. There's a lot of websites that work this way. If immediacy is not your goal, if maybe at the end of the day you need to put in a timesheet. I mean, there's a lot of accounting purposes where, by 5 p.m. that's when they want all their data finalized. So this is kind of that use case for that kind of scheduled back end where you're not in a hurry and you want to stamp a lot of files at once. So this one lets you upload a group of files. So we're going to scroll down, take some that are in the, 400s. We're going to pick 3 of these files. Now I've selected 3 files. They're not already in this list. If I click upload 3 files, you can see now that they're just kind of hanging out and they're waiting, and our collection isn't fully stamped. If we waited until midnight, so I could wait another 2 hours, and these would automatically stamp if this demo was running, but we're going to hurry it along and click stamp collection now. That's an example of how to group together and stamp a group of files at once. So we'll check our event stream, and we can see that all of them basically were in lockstep, so they were uploaded as 3. They all got kind of stamped at the same time, and it's kind of still loading some of the images. Okay, so that's how scheduled file stamping works. We're almost through it. I promised you a quick demo. Okay, so that was example 5. We're going to look at example 6. Example 6 we don't run from the console because it's literally a client example. So what it's going to show you is how to do a local hash. Reveal in File Explorer. Double click the index file. So what this does is it lets you drag in any file on your hard drive into this little box here, and it will tell you the calculated hash, and it's doing this client side. So this is how you can calculate the hash for verification or for any other purpose, private files, without uploading it to any server. And the kind of trick there is using the multi-fx something library. I'll show you. So in this simple, so we're using multi-hash with these very specific settings that come from IPFS. I didn't make this up. This is just what they are. So you have to use this exact settings. And we have a function CID hash, and it's using client-side JavaScript and the IPFS Unix FS importer, which you get from a library that you can include, to just calculate it locally. It calculates the hashes, and then it shows it very quickly without having to upload and incur the bandwidth to upload the file to have your server do it, and then all the server overhead. It's just a mess. So if you're doing like a huge list of files that a user has selected and you want to do something to see if they're verified or if they're part of your set, you'd want to do as much of that locally as you can. Okay, I won't dwell on that, but this is just a complete and working example of how to do a local hash. And the next level up from that is creating an actual receipt file that makes the file unmodifiable. So what do I mean by that? I mean that if I take one of these certificates and I drag it in here, it's going to return back a zip that contains the file that I dragged in, the content ID, and this is a .cl stamp file that's sitting currently in my downloads folder. So I'll move it to my demo folder here so we can take a look. So this archive, which is actually, it's really a .png.zip.cl stamp. So the original file in here is martinamberson.png. If I remove the .cl stamp, then I can open it. But the reason that we created an extension like this is so that somebody doesn't come in here and accidentally modify this image. Like if this image was sitting loose on your phone might go in and resize it down to save space. If this is a Word document, you might accidentally open it at some point, which actually changes the data inside the Word document, and it would mean that the hash wouldn't resolve anymore. So these special .cl stamp files can be verified, and what actually gets verified, and it's only true for CL stamp files, is the contents. So if I drag this into the Chainletter verification tool, it's going to look up the file that's actually inside and kind of locked away in this zip, and the bytes of that file can't change, the hash can't change. So that's why this example is included here. It just lets you show on the client side how you can take a local file from someone's computer, zip it up, hash it, and return it back to them as a receipt file, all without any kind of bandwidth or uploading humongous files. So this, if you want to do a 4 GB video file, it'll do it in 2 seconds, locally. You don't have to upload it to some server and wait. Okay, that's that example. And then finally, we get to more examples we can run from the client. Example 8, which is uploading and getting a CL stamp. Okay, so we've loaded example 8 in our browser. I'm going to select a file. We could use this person again. Drag it in. And now we've actually uploaded the file as normal, so it's combining aspects of the API. The file's been uploaded. It's been uploaded to our cloud host. It's been stamped all at once. We have an IPFS hash of the file. And if I click download.zip.cl stamp, what this is doing is a little bit tricky because it's not downloading the one from the server or from IPFS. It's still got it in this file browse dialog, and it's zipping it up using the previous example. So by using tricks like this, you can make your app much more responsive and incur a lot less bandwidth and do a lot less on your server. So that's kind of, it's a tips and tricks as well as a way of just examining all the functionality you might need to do to integrate Chainletter stamping into your your back end for your credentialing system or any kind of automatic algorithm that you want to embed it in. So hopefully that was a good demonstration of what you can do with our Webhook API that we've created, and I'll add more, but hopefully it serves as a good menu sampler here. I still have one last demonstration, and it's the ability to let users claim a certificate. Since this involves more layers of the system, I saved it for the end, and the only example that actually shows it in action is example 2, which is the quiz. But there really isn't much of a UI right now on the claim site in this example because we're using my development environment. But in the live site, the claim site would be the institution or business that is using our platform and has a private label with us. So I'm just going to show you what it is, and then I'll show you a little bit of code, and it should hopefully make sense. So if I'm going to complete the quiz again, I'll put in the correct answers. They never change. And I'm going to put in a new username, and we're going to say July 12th. I'm going to submit the quiz. And you can see that we got our response back. There's no transaction ID yet. All of this is looking pretty normal. I'm going to clear my network panel. And we have a secret claim link. That's one of our fields. And if I click this link, I'll be able to claim ownership over this certificate, which is pretty powerful because it adds it to my profile, which I can then share on LinkedIn, and I can share with other people who can verify on the blockchain all of my certificates. Let's refresh to see if we got a transaction ID. Yes, we did. So this is a complete certificate. You can see it's been issued, and I put in a date instead of a name, but it's right here. And then if we look in our traffic that we've been sending back and forth, there's a new section in the data that's returned by the API. Now you can, this is all pretty much the same. It gives you the transaction ID, most of the fields are displaying, but there's a section down here, export data, and since I sent the header export links to true, it sent back this permalinks, which is giving me a short URL here. I know it's a lot. That's linking out to the claim portal that's registered with this site. And if I use that link, I can actually claim that certificate and add it to my profile. There's also a permalink CSV field that's returned, and this is a file that actually would have all of the permalinks from that entire collection of certificates that you can then download. Although it's limited to just this single one, since in this use case we're really not going to want an end user to see a whole list of all of the other claimable stuff from our group. We only want them to see the one. Okay, so what does that look like in practice? If I click on the secret claim link, it opened a new tab, and since I'm already logged in to the fake private label, which in this case is called Dev API, it's saying that I can claim my blockchain-backed file. I have a profile here that I've already set up previously. If I click on free and claim it, my free item has been claimed successfully. I can find it on my profile. If I go to my profile, now I tested this once before, so we actually have 2 in here. But we should see July 12th. If I click on that, here's my verifiable certificate of completion, and it goes through all the blockchain verification. It says who stamped it, it says who issued it, it says who it was issued to. So this is a kind of end-to-end demonstration of how, if you were doing something like an online training course or something where on demand someone was receiving a verifiable certificate using the API to automate the process, this is the end result. And this would, like I said, it would be in your university's or your business's private label site. So in the code, the only thing that you really have to do to change to get those export links is this is a server. On your server call, which is sending your API secret, which is what unlocks this, you have to send export links in the webhook's get. As long as you set export links to the string true, then you should get back those objects that I showed you in Chrome. And that really just completes all of the demos. It shows you how to use pretty much every aspect of the Chainletter system. It's all available, and if there's any features you think I missed, feel free to let me know, and I'll see if I can get them added. Thank you.